2.4, using postulates and diagrams. Before we start this lesson, we need to review what a postulate is. Postulate is a statement that we accept as being true without it having to be proven. And they're usually numbered. Now, there's not a standard list of numbers for these postulates because different mathematicians throughout the years started with their own numbering system. So our book may call it postulate 5, but somebody else's book may call it something different. So we're not going to use them as the numbers themselves. We're going to say that when we use them as evidence and a proof, we can say because there can only exist one line through exactly 2 points. So don't try to memorize these by the numbers. Memorize them by the words. Okay. So before we start this, too, we need to have one vocabulary word. How would you define a line perpendicular to a plane? Okay, let's use a biconditional statement. Remember that is having if and only if. So a line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. Now, a lot of times it's easier to see these things through a diagram. So here we have a plane and a line coming through at the point, and we could say this is perpendicular if it's also perpendicular to any line that you can draw on this point, like this. If it's perpendicular to all those, it must be perpendicular to the plane. Okay, so here are some of our postulates. Before we start this, let's review what postulates 1 through 4 had. And if you forget these, they're all listed for you on page 926 of your book. Let me write that down somewhere so you can look back and know where that is. It's in the very back. So our first postulate of this book was the ruler postulate. And that meant the points on a line can be matched 1-to-1 with real numbers. So we can hold up a ruler and say this is position 1 and that is position 2. The second postulate was if B is between A and C, then we can add those two parts together to get the total. So AB plus BC equals AC. Protractor postulate. We can line up an angle on a protractor and match it to a number. 4. Angle addition postulate. If P is in the interior of an angle, then the two smaller angles that it makes add up to be the larger angle. And then here's postulate 5. through any 2 points, there exists exactly one line. Postulate 6, a line contains at least 2 points. Now we know there are many, many more points, but that's a true statement. It contains at least 2 points. Postulate 7, if 2 lines intersect, then their intersection is exactly 1 point. Through any 3 non-collinear points, there exists exactly 1 plane. So, postulate 9, a plane consists of at least 3 non-collinear points. If 2 points lie on a plane, then the line containing them lies on the plane. Postulate 11, if 2 points intersect, then their intersects, no, not points, if 2 planes intersect, then their intersection is a line. So, example 1. Identify the postulate illustrated by the diagram. You got 3 points, if then they're on a plane. So we can say, and again, I'm not going to make you memorize them by the numbers, so just leave that blank. But we can say through any 3, what? Not just 3 points, but 3 non-collinear points, there exists exactly 1 plane. Okay, use the diagram to write examples of postulates 9 and 11. So postulate 9 says that the plane contains at least 3 non-collinear points. So what plane is this? This is plane Q. And we know it's plane Q because it doesn't have a dot after it, so we're not naming a point, we're naming the plane with the Q. And then what 3 points are on this plane? So we can say point W is on this plane, point V is on that plane, and how about point Y? Now, if we had another point down here, that might be trickier because these 3 are in a line, so we couldn't have used that. So we could use these 3 because they're not on the same line. Okay, postulate 11 talked about the intersection of 2 planes. So the intersection of plane P and plane Q is a line. And what is that line named? Line B. Okay, checkpoint. This postulate allows you to say that intersection of A and B is a point. And then write examples of postulates 5 and 6. Okay, start again when you're through. Concept summary. Interpreting a diagram. When you interpret a diagram, you can only assume information about the size or measure if it's marked. So you have to be really careful not to assume that something's true just because it looks true. We have to tell you it's true. So we cannot assume that all points shown are coplanar. Unless we tell you. Because even though they all look like they're on this plane, they might not be. So AHB and angle let's find that one. AHB and angle what are a linear pair, and BHD. Okay, I think they have messed this up. And I'm very sure they have messed this up. So, instead of going back to the first and trying to re-record this, let's go back. We can assume. Okay, so I was thinking, man, it'd be hard to tell whether they're coplanar or not. So we can assume that these are coplanar because they did not write them, show that somehow they were coming out of this plane. So that's fine. AHB and what? BHD are a linear pair. Yeah, sure, they make a line. AHF and what? BHD are vertical angles. AH, J, and D are collinear. And AD and BF intersect at point H. Okay, now let's go to the things you cannot assume. You can't assume that G, F, and E are collinear. Why can't we assume that? Because we didn't draw the line through it, or the diagram itself hadn't drawn the line. So one of them may be off. Okay, what else can we not say? BF and CE intersect. Looks like they do, but again, it's not on the diagram, so we can't assume it. BF and CE do not intersect. Again, it's not on the diagram, so we can't assume that. Angle BHA and angle CJA are equal. Just because they look equal doesn't mean that they are equal, unless we draw a little hash mark with angles. And AD is perpendicular to BF, or the measure of AHB is 90 degrees. There's no box symbol written on that, so we can't say that they are perpendicular. Okay, example 3. Use the given information to sketch a diagram. Sketch a diagram showing RS segment perpendicular to line TB, intersecting at point X. Draw the segment RS and label the points R and S. Draw point X between R and X. And then draw line TV through X, so that is perpendicular to RS. Over here at the notice box, notice that the picture was drawn so that X does not look like a midpoint of RS. This is helpful so that we don't make false assumptions later on based on what the diagram looks like. So we try to draw the diagram so that we're not going to unintentionally fool anyone. Okay, example 4. Which of the following statements cannot be assumed from the diagram? E, D, and C are collinear. E, D, and C are collinear. Do they have a line drawn? Yes, they do, so that's fine. How about the intersection of line BD and EC is D? Line BD and EC is D. So that's fine. Two lines drawn through and a point there. How about BD is perpendicular to EC? Okay. That one we can't assume because there is no right angle mark. So And then EC is perpendicular to plane G. Again, no angle marks, so no. Okay, checkpoint. Complete the following exercises. Bring these to class tomorrow.